Let's see question 28. So we want to simplify those radical expressions. So let me get my pencil. Okay, let's see. The index is a 3. So the index is 3. We're looking for the exponents in the radicand to be multiples of 3. So 27 is a 3 raised by 3. So we would write 27 as a 3 raised by 3. And the x raised by 12, that's perfect, because 12 is a multiple of 3. 12 divided by 3 is 4. So what's the answer for this? The answer for this will be 3 and the x raised by 4. Okay, let's see why. Remember, we can write radical expressions in rational exponents. So we can write cubic root of 27 x raised by 12 as 27 times x raised by 12, then raised by 1/3. Right, raised by 1/3. Then 27 can be written as 3 raised by 3. So this equals to, so we distribute 1/3 to the exponent of 3 raised by 3 and to x raised by 12 to the 12. So basically we have 3 raised by 3, then raised by 1/3 again, multiplied by x raised by 12, now raised by 1/3 again. So when the base has 2 layers of exponents, we multiply those 2 exponents. So we multiply 3 with 1/3, we multiply 12 with 1/3. 3 times 1/3 is just 1. So 3 raised by 1. We don't bother to write the 1 as exponent of 3. Just by default, 3 is 3 raised by 1. The x raised by 12 times 1/3, which is 12 divided by 3. It's x raised by 4. So similarly for B, but B is a little bit tricky because we have this one index 6, this one index 3. So what do? We would multiply by a rational exponent of 1. So we would raise the second one by 1, but this one, remember 1 is a transformer, is a number divides itself. So you want to raise this one by 2/2. 2/2 is 1. So the power will apply to inside the parentheses. So the numerator 2. The numerator 2 is exponent of the radicand. And these 2 in the denominator will apply to the index. So I have a square root of this whole thing. So 2 layers of radicals is the similar to 2 layers of exponents. We multiply the 2 index. So the second one becomes 6 root. So we have 2 times 3, that becomes 6. 6 root of a square, that becomes a to the 4th power. Then b squared. Then we multiply those 2 together. Now, those 2 with the same index, we multiply those 2. With the same index, now we can put the radicand together. So the first one, we have ab squared. The second one, we have a to the 4th power. And the b squared. we're looking for the same base. Once we have the same base, multiplication indicates adding their exponents. So we have a to the 4th, that becomes a to the 5th, a to the power 5, right? Because the power a here is 1. 1 plus 4, that's 5. And for b, we have 2b squared. Well, b squared times b squared, that's b to the 4th power, because 2 plus 2 is 4. So this is our answer for B. Now let's see C. C, the index in the numerator is 4. Index in the denominator by default, that's 2. We would play the same trick, right? We want to add another layer of index. We square root this, then we put the power. Same as before, we raise by 2 over 2. So that means the power we raise by 2, and the index we also have 2. Then with 2 layers of index, 2, 2, so we multiply. So we also have 4th root in the denominator now. So we change this to 2 times 2 is 4. So we also have 4th root in the denominator. But look at this x being squared, y being squared in the denominator. Once we have the same index, we can put the radicand in the numerator and in the denominator together. So numerator will have x cubed, y cubed, divided by, look at this down below here, we have x, y raised by square. That means x raised by 2 and y raised by 2. Well, now we can simplify because they are all under the 4th root. We can simplify. X raised by 3 divided by x squared, same base. Division indicates subtraction of the exponents. So 3 minus 2, that's 1. So for x, we just have x raised by 1. Same thing for y, because the exponent of 3 minus 2, which is 1. So the answer for C is the 4th root of x times y. For D, we still have 2 layers of index, 5 and 3. We just multiply them. 3 times 5, that's 15. So it becomes 15 root of 2x. The radicand stays the same. For E, let's see how we simplify 90. 90 can be split into square root of 9 times square root of 10. Right? And square root of x cubed can be split as x squared times x. Right? With the same radical, we can split into 2 radicals with multiplication. Now we see this is perfect square. So this one becomes 3x. Right? Square root of 9x squared becomes 3x. Then we still have 10x under the square root. So this is our answer for E. For F, we see 25 times 2 is 50. Right? So square root of 25 is 5. And x raised by 5 can be split as x raised by 4 times x. X raised by 4 square root x squared. Y raised by 7, we split into y to the 6 and times y. Y to the 6 square root becomes y to the 3rd power. Then what's left under the radical? 5 is square root of 25. So 50 is 25 times 2, so we still have 2 here. X raised by 5, x raised by 4, square root, x squared out. So we have x left. Same for y and z. So our answer for F is 5x squared, y raised by 3, square root of 2xyz. Okay, now I have erased all this. So I have, let's move this up. Let's see for G, can I put them together? Okay, let's do G first. So let's look at G. Now our index is cube. We're looking for power 3 again. 6 is perfect because 6 divided by 3 is 2. And 8, we want to split it into 6 plus 2. 6 plus 2. What about number 28? 48. 48 is 3 times 16. Or 6 times 8, right? 6 times 8. Why 8? Because 8 is a 2 cube. And the cubic root of 48 is just this. Cubic root of 6 times 2 raised by 3. And this one simplified to be 2 and the cubic root of 6. Okay, so now let's put the answer here. So I have 2. The x term, I have 2, x raised by 2 because 6 divided by 3 is 2. And the y also has square because 6 divided by 2 by 3 is 2. So this is outside the radical sign. Now what's to stay inside the cubic root? I still have 6. Right? I still have, do I have x? I don't have x anymore, right? But I do have y squared. And that's it. So this is the answer for G. Let's look at H. The index is 4. We're looking for power exponent to be 4 or multiples of 4, like a 4, 8, 12, 16, so on and so forth. So 8 is fine. We don't want to change anything about y. 12 is fine. We don't want to change anything about z. Well, let's see x raised by 5. 5, probably we want to write as 4 plus 1, right? That means x raised by 4 times x. What about 162? Well, let's do short division about the 162 to look for the hidden to the fourth power. So let's divide by 2. Let's divide by 2. If we divide by 2, we have 81. Obvious now. 81 is a 3 raised by 4. Right? So 162 can be written as 2 times 3 raised by 4. So now 3 comes out of the fourth root sign. Right, then x raised by 4 with fourth root x. Y raised by a with the fourth root, that becomes y squared. Z to the 12 and the fourth root becomes 3z to the power third. What's left inside? For number, we still have 2 left under the fourth root. The index is 4, fourth root, and with x. So this is the answer for H. 3xy squared z cubed with fourth root of 2x. Let's see I. I both under square root. So we can just put them together, right? Put them together. We have 7 times 12, or 12 is 3 times 4. We know square root of 4 is 2. So first we have 2. Then x squared, square root, that's just x. And we want to force, or we don't have to, because this x is here. Sometimes we want to force x to be positive, we put an absolute value sign around it. But for this one, we don't have to, because x is already under square root. So we have 2x. Now what's still under square root? We have 3 times 7, that's 21. And then we have x. So the answer for I is a 2x square root of 21x. Let's keep moving. For J, we have index 3, same index. We just put everything under the same index. We have 12 times 4. Now we're looking for the power to raise to the power 3 or 6, so on and so forth. So 12 is 3 times 4, right? So 3 times 4. 4 is 2 squared. And then this one we have 4. 4 is 2 squared. So we have 2 raised by 4. 2 squared times 2 squared is 2 raised by 2 plus 2, which is 2 raised by 4. Then for x term, we have x squared times x, that becomes x cubed. For y term, we only have y to the 5th. Right? Now we think about a split. So 2 is 2 raised by 4. We want a 2 raised by 3 first. Then we get 2 outside the cubic root. Then for numbers, oh, hold on a second. Let me finish the variables also. For the variables, x cubed, then cubic root, that's just x. Y to the 5th power can be split into y raised by 3 times y squared. So y comes out. Then what's stay inside the cubic root? I have 2 times 3, 6. X raised by 3, no more inside. Y raised by 5. Y to the 3rd is already simplified, and then we have y squared. So the answer for J is 2xy times cubic root of 6y squared. For K, both under index 3. So we multiply the radicand, same index, we put them together under one cubic root. So then we have x plus 4 times x plus 4 raised by 22. Now this is raised by 1. So the base, looking x plus 4 as a base, as b raised by 1, b raised by 22. So we can combine those two, right? So x plus 4 raised by 22 plus 1, which is 20, raised by 23. But usually we want to simplify it, right? 23 cannot be divided by 3 evenly. So we want to break into 21 plus 2. Because 21 divided by 3, that's a 7. So what's the answer for this? We have x plus 4 raised by 7 all side, because 21 divided by 3, index 3, 21 divided by 3 is 7. Then, but we still have this 2, 21 plus 2, right? 23. We still have x, so cubic root of x plus 4 squared. So what did we do? We first put the two radicands together to multiply each other because they're under the same cubic root. Once we do that, we look at x plus 4 as a base. So the first one have x plus 4 raised by 1. The second one, second radicand, we have x plus 4 raised by 22. So same base, we're adding the exponents that become 23. But in 23, we're looking for multiples of 3, which is 21, right? The highest one. 21 divided by 3, that's a 7. So that's why we have x plus 4 raised by 7 outside the cubic root sign. And inside the cubic root sign, we still have x plus 4 raised by square. Now let's say I. Same index, 3. We put them together and the one cubic root sign. 4 is 2 square. 6 is 3 times 2. So first we can pull out 2 and 3 stays inside. We have x raised by 10, x raised by 16. That's x raised by 26. Right? 10 plus 16, that's 26. 26 divided by 3, we better use 21. No, 24. right? 26, we want to split into 24 plus 2. Because 24 divided by 3, that's 8th power. So we have x raised by 8. Then for y term, we have y to the first power times y to the 14, which becomes y to the 15th. So 15 divided by 3, that's 5. So y to the 5th power. Then we're looking for under square root sign. We see 3 is still there, right? Because 3 times 2, 6. And this 2 with the 4 becomes 2 cubed. So we still have 3 left. Still have 3 left under the cubic root sign. And x, we have x raised by 26, but I will only need x raised by 21. Oh, hold on, yeah. X raised by 10, x raised by 16, so x raised by 26. We only want a 24, right? X raised by 24. 24 divided by 3, that's x raised by 8. But we have 26, so we still have x squared inside. What about y term? Y is y to the 15th power. 15 is the power of 3. So we get a y5. So the answer is 2 times x raised by 8 times y raised by 5 times the cubic root of 3x squared. Now let's change a little bit. So now we want to add two radical numbers. And we need to make them like a radicand, like radicals. So once they're like radicals, we can add the numbers before the radicals, right? Let's see, the first one, we have square root of 5. Square root of 5 is simplified. So we have 3 square root of 5, because 3 multiplied by square root of 5. But square root of 125 is not simplified. 5 times 25 is 125. But square root of 25 is 5. So this one becomes 4 times 5, which is 20, times square root of 5. Right? Because 125 is 25 times 5. Square root of 25 is 5. 5. What did I write? So I have 525. Okay, so square root of 125 is 5 square root of 5. Then there's a number before it. This is multiplication. Oh, I already read 20. So 4 times 5 is 20. So 20 radical 5. So this number is 20 radical 5 and 3 radical 5. So totally I have 20 plus 3 of radical 5. So the answer for M is 23 radical 5. Okay, I better erase this, right? Too much on the board. So M is 23 radical 5. Now let's see N. We're also adding, we're trying to subtract 2 radicals. So we need to make them like radicals. Like radicals means the index are the same and the radicands are the same. Right. Radicand. Radicand. I hope I hope I'm writing it right. Radicand. And the number here, whatever the number is here, let me put an M, it's called an index. Okay. Or you can read as M's root. M, okay, let me write it down here. M, you read it as M's root of the radicand. Okay, or just radical with the index M. And the sign is called a radicand. Okay. So like radicals means the index are the same, the radicands are the same. So how do we simplify square root of 28? 28 is 4 times 7, right? So we know square root of 4. So let me just write here. So that equals to 7 times 4 times radical of 4 times 7 minus 3. Same thing, 63 can be factored as 9 times 7. Now, we know square root of 4, which is 2. So that becomes 7 times 2, square root of 7, minus square root of 9, which is 3. 3 times 3 times radical 7. So we have 14. So 2 times 7 is 14. We have 14 radical 7. We have 9 radical 7. Now you see we have a like radicand. We have like radicand, square root 7, square root 7, called like radicals. Because the index are 2, the radicand are 7. And 14 of radical 7 minus 9 of radical 7, we just subtract 14, subtract 9 from 14, so we get 5. So the answer is 5 times radical 7. Let's say, oh, same thing, we want to simplify to have like radicals. Right? We see 8 is 2 times 4. So 8 becomes multiplied by 2. Square root 4 comes out as 2, but we still have 2 inside. And the x, 3 can be broken into 2 plus 1. So x comes out, but we still have 1x inside. And of course, we have y. So the first one simplified to be 2 times 5 is 10. Let me write it here. 10x square root of 2x y. Okay. Then plus the second one. How do we simplify the second one? 32 is 16 times 2. Well, square root of 16 is 4. 4 times 2, that's 8. Right. So the number we have 8. Then we have 8x. Then 16, square root of 16 comes out, so I have 2 left. So we also get square root of 2xy. Now we have like radicals, which is square root of 2xy. Once we have like radicals, we can just add the numbers or expressions before them. So we still have 10x plus 8x. That's just 18x. So our answer is 18x square root of 2xy. That's for O. For P, we have this cubic. The index is 3, cubic root. Right? So 64 is 4 raised by 4 times 4, 16. 16 times 4, 64. So it's 4 raised by 3. X raised by square, well, square 2 is smaller than 3, so stays inside. So the first one becomes 4 cubic root of x squared. So let me write it here. So P, 4 cubic root of x squared. Minus, well, 125 is 5 cubed. So that becomes 5 cubic root of x squared. Again, we have like radicals. The index are 3 and the radicand x squared. So I have like radicals, right? This part is the same as this part. So basically, in the cosine, the two are the same. Then we have 4 minus 5, well, which is a -1, right? So we get negative cubic root of x squared. So this is our answer for P. Let's see Q. Q, the numerator is square root. The denominator is square root. So we can put them together, right? Under 1 square root sine. Then we see 2 goes to 32 16 times. Okay, so get a square root of 16, 32 divided by 2, that's 16. X raised by 9 divided by x, that's x raised by 8. Well, all under square root sign. 16 is 4 squared, right? So that comes out as 4. X raised by 8 comes out as x raised by 4, because 8 divided by 2 is 4. So our answer for Q is 4x raised by 4. For R, we're also under the same index 3. So we can put this numerator and denominator under 1 cubic root sine. Now we can simplify. 5 goes into 24 times, so I have 40. We have cubic root of 40. Then x raised by 10 divided by x raised by 4. We subtract the exponents. We have x raised by 6 cubic root, right? Then we're looking for something raised by third power to be a factor of 40. Well, of course, that's 5 and 8, right? Because 8, number 8 is 2 raised by 3, 2 cubed. 2 times 2 is 4. 4 times 2 is 8. So that means 2 comes out of the cubic root sign, and x raised by 6 come out of the cubic sign, becomes x squared. Then what's left inside? We still have this 5. They only have this 5 left inside. So we can write this as 2 radical 5 x squared, right? That's R. Now let me erase a little bit so I can have more space. Okay, for S, we want to FOIL. We said we have 2 binomials, right? We have 2 binomials. So we want to multiply first one with first one, second one with the second one. We call this a FOIL. I like to call it, smiling face. Look at this. Isn't this a smiling face? Right. Multiply square root. Maybe I'm going to use pen. So this equals to square root of 14 times square root of 6. I can put both under the same square root sign. Then minus 3 radical 5 times 2 radical 5. So 3 radical 5 times 2 radical 5. This is above, right? Then the bottom I have 3 radical 5 times radical 6. Times radical 6. The inner 2, right? This inner 2. Then the outside 2, positive times negative become negative. Negative square root of 14 times 2 radical 5. So now let's simplify it. 6 is 2 times 3. 14 is 2 times 7. So we see 2, we have 2 squared. 2 square root becomes 2. Right? Then what's left? We still have this 7, we still have this 3. So square root of 21. Square root 21, just square root 21 cannot be simplified. Now minus, we have this 3 times 2, which is 6. Then we have radical 5 times radical 5. That becomes radical 5 squared, which is just 5. Then plus 3, radical 5, radical 6, doesn't have a hidden square. So we just do 5 times 6, which is 30. So 3 radical 30. And last one, we have square root 14 times 2 square root of 5. So this is minus term. Minus 2 times, well, 5 is a prime number. And 14 is 2 times 7, so there's no hidden square. So we just do 14 times 5, which is 70. So 5 times 6, that's 30. This one can be simplified. And then nothing else can be simplified. We have 4 terms. We have 2 square root 21 minus 30 plus 3 radical 30. Right. The minus 2 times the square root of 70. So this is the answer for S. Let me erase this so I can have space for T. T, let's see the difference between T and S. S, I have a binomial times a binomial, which means I have 2 terms multiplied by another 2 terms. So I do FOIL or smiling face. But this, I have a monomial, but times a binomial. So what do? I just distribute this monomial. I multiply those 2. I multiply these 2. Right. Multiply these 2, just 3 times 1, just invisible 1. So I get 3 outside. Then I have a cubic root of x times cubic root of x. I can put a cubic root of x times x, which is cubic root of x squared. Okay, first term. Second term, 1 times 4, which is a negative 4. I write down this first. Then I have a cubic root of x times cubic root of x squared. So let me just write down. I have a cubic root of x times x squared. What's x times x squared? X cubed, right? So this term becomes 4x. Because x cubed, then cubic root, right? So it becomes x. So the answer is 3 and third root of x squared minus 4x. 29. Let me see how many questions. If too many, maybe I'll leave for another. Yeah, I'm gonna leave for another video, okay. Okay, let me leave this for another video. Let me rest a little bit.